So I'm going to do a quick review of the difference in difference method. And the question we're going to use to review this is whether the elimination of co-payment increased the number of visits to the physician. And the specific example is a reform in Norway in 2010. And the reform ended co-payment for young people that were below 16 years old. So before 2010, if you were 14, you had to pay. After 2010, you did not have to pay when you went to the doctor. So the question is whether this actually increased the number of visits to the doctor. And the method we're going to try to use to explore this is called difference in difference. So we can have a look at the 14-year-olds, which is the treatment group, and the control group would be some other age group that's not affected by the reform. So it could be 20-year-olds or 40-year-olds, or it could be 8-year-olds, but not those between 12 and 16. So that's going to be the control group, and we're going to compare it to the 14-year-olds and see if there's a sudden jump in the difference between the groups before and after. So that's a specific thing. We need to use some tools. So this will be the standard tools. You're going to use pandas to store the data. You're going to use stats models to do the regressions, and NumPy to help us do some things as well. So let me see, I have a typing mistake here. Formula. There we go. So this will be our tools. Now I put a file up here. So this is in Dropbox, and this is actual data on number of visits. And for some reason, I just before I look at the data, so I have somehow determined that I would like to use visits instead of consultations. Maybe it's too many letters to type or something. So this is the data. We have the year and the age group and the gender and the total number of consultations in that year for that age group, for that gender, the total population in that age group. And from that, we can calculate per capita visits in that age group. And also then I call this visits here. Okay, so we're going to focus on per capita visits, which makes me wonder why I actually created the visits and consultations. Now we have two names I don't use. Okay, something happened there. So first of all, let's just try to find the average number of visits in different age groups. And let me just take away the results now so you don't see the results. Let me collapse, insert, edit, clear all outputs. Okay, so you're going to see everything again like it's fresh. So we're going to find the average number of visits for every single age group. So what we're going to do is basically take the data frame we have. If you look at this data frame, and we're going to split it into different age groups. So all the rows for the 1-year-olds, that'd be in 2006, 2007, 2008, we have the number of visits per capita for 1-year-olds. And the same for 2-year-olds and 3-year-olds. So we're going to group by age because we want the results to be by age in this case. And we want to focus on the variable per capita. After we have split the data set on age, we're going to focus on per capita. We want the mean number of visits per capita, and we're going to plot it. So you get something like this, which is interesting. So here we can see the number of visits for 20-year-olds and 40-year-olds and 60-year-olds and 80-year-olds, how often they go to the doctor. So on average, for instance, the 20-year-old would go about twice to the doctor. And these are, I think this is only females. You see it goes down until you're like 12, 15 here, and then it starts to rise again, and goes up. And this, I think, is special for females because it's childbirth. So you have more visits to the doctor here. But that's the pattern. So that's interesting. But that's nothing to do with the difference in difference, right? This is just to see the age pattern. It could have a little bit to do with it. So if you want to choose a comparison group, like say if you have 14-year-olds, then maybe you should compare them not to 80-year-olds or something, because they have very different patterns. Every 80-year-olds, they are on average like 4.5 visits to the doctor. So they're probably a little bit different. Now, let's just look at the 14-year-olds and see if there's a time trend, if it goes up or down over time. Remember, we have visits in 2006, 2007, and so we want to see if the average number of visits goes up or down. Let's start by just selecting the 14-year-olds from data frame. So we're going to work with only the 14-year-olds. The way we do that is I created a new data frame. I called it data frame for 14-year-olds, DF14. And we're going to take the original data frame and just select those who are 14. We do that. Now, if you look at this data frame, DF14, and if you want to graph the per capita visits, right? This is the variable we're interested in. And you want the year to be to the left here, where you have 13, 102, 100, that's the index. Because we used to have more observations, but now we selected only the 14-year-olds, so we're stuck with these ugly numbers, 13, 102. So instead, I want to have a year as the index. And then I can graph it, because then you get a nice x-axis, where the year is the x-axis. So I will take the data frame, I will set the index to be the year, meaning I'm just putting year to the left here, focus on per capita, and plot it as a bar plot. Okay. Which is interesting again. We see there's a small jump in 2000, between 2009 and 2010. But we also see there might be a small trend over time also. But there seems to be a distinct jump here. So that's like the first thing. But it could be something else. It doesn't have to be the reform. It could also be something else. We have to be a little bit careful. So that's why we're going to do the difference and difference. We have a control group. Now, in order to run this method, let's just again visualize it a little bit, and let's say we're going to visualize it with 25-year-olds. So we want a graph where we have both 14-year-olds and 25-year-olds, line graphs, and we want to see if there's a difference between the trend in those graphs. So I'm just going to take the data frame and get only those who are 14 and 25 here. And we're going to focus on only 3 variables, in this case, the year, the age, and the number of visits they have per capita. So that's why I'm doing this. I'm just going to focus on those 3 variables. I mean, there are more variables here, but we don't need them. So that's what we get. We call this data frame number 2, right? So year, age, and per capita. That's all the information we need. Now, one way of getting a graph from this is, you see here, 14, 25, 14, 25. They're stacked on top of each other. So there's a simple way of unstacking this. And it's just saying unstack. So let me do that first. So if I want this data frame and I want it to, there are many ways of getting this graph I'm trying to get at. You can do a group by, but now I'm setting the index to be year and age. So I'm taking those 2 variables and moving them basically to the left. So that's the index variable. In this case, 2 variables as an index. And then I'm unstacking it. Basically, this 14 and 25 now will not be in as rows, but there will be columns. I'll see what it's easier if you see it. You see, now I have one column for 14-year-olds and another column for 25-year-olds. So that's what unstack does. It takes a variable that's stacked and unstacks it. So if you do that, then you can plot it, and you'll see what you get. Plot. You have to do a line. We'll see. Plot this, and we get, yes, one line for the 25-year-olds, another line for the 14-year-olds, and there seems to be something going on here that it's kind of flat. There's a jump here again between 2009 and 2010. And I don't think there's not a similar jump for the 25-year-olds at least. Okay, so now we have some visual expressions. Let's do the formal analysis. And in order to do the formal difference and difference analysis, we have to shape the data set a little bit again. And just for fun, I'm going to choose 45-year-olds here. So we'll see, again, 14 and 25, right? No, so did I say 25? I said 45. I meant 25, didn't I? Yeah, they're 25 now. Okay. 25 and 25. I'm going to, okay, this is going to be, I have to do that all the time, right? It's just life. You're going to compare the developments for 14 and 25-year-olds. The first thing we have to do is that we have to create a variable that says something like whether the intervention is on or off, basically. And I'm going to start by saying it's always off. There's no intervention. And then I'm going to say that if the index, the year, is less than 2001, then it's going to still be 0. But if it's not, if it's more than 2009, then it's going to be 1. Basically, we're creating a dummy for when the intervention is on. And we're going to do 25 here, and we have to do 25 here. This is going to be painful, isn't it? 25. And 25 here as well. So first, I'm just creating a new variable, and it's going to be 0 for before 2009 and 1 after. There's probably easier ways of doing this. I just did this in a hurry here, and we have a problem. Ah, there, see, I missed it. 25. Okay. So have a look at it. So I gave this a new name, data frame for 14-year-olds and 25-year-olds. So let me do that. And yes, we have 0, 0, 0, 0, and then 1 in 2010. So that's good. Let's just compare the group means. So how many visits did they have in the different, like before and after the intervention? So I call the intervention here copay, right? That's a dummy for before, and it becomes 1 after. So let's just compare the number of visits before and after for both groups. And it's still 25. Okay. So we can see that 14-year-olds, they have fewer visits. They have about 1 visit a year before the intervention and 1.24 after. And 25-year-olds, they have almost 3 visits. And it's not the gap or the jump between 0 and 1, also the gap between before and after. It's not so big for the 25-year-olds. It's easier if I just work with the columns here that are age. So let me do that. So I'm going to say results, and I gave it a name. Now we have these results, and now I can just subtract. What's the difference between, oh, I called it age 45 now. I should have called it age 25. Yeah, pain, I told you. See. Now, what's the difference between age 25 and age 14 before the reform? I can do this to get the difference before, and I can do the same thing to get the difference after. So here you have the difference before and the difference after, and the difference between those two. Let's just take the difference again. And now I have the difference in difference result. It's negative 0.15, meaning that the difference between those two groups became smaller, which indicates, if you go back to the graph, that here you had a certain difference here, right? And after the reform, this distance was smaller, which means that either the yellow thing had jumped up, but that's not the case, which means that there was probably an increase in number of visits for 14-year-olds, right? Because you had a difference here, and now the difference is smaller, so the lines are closer, so this one has to be bigger. Okay, so but that's just one way, and that's actually one way you can do the analysis. You can just calculate the mean before and after, and compare the means for both groups. So that's a perfectly fine way of doing a difference in difference. Now, mainly we do that, of course, when we only have one observation before and one observation after. So let's do it using our regression. Again, I think I already have this variable, so we don't need to do it. Let me see if we have this variable copay, right? No, we don't have this variable here, copay. Okay, so I'll create the copay variable. Again, it's the same way of creating it. First, I set it to be 0. This is going to be a variable that is 0 before the intervention and 1 after. So here we have a copay variable, right? So now the data is structured as follows. We have year, age, per capita visits, and whether there was copayment or not. Meaning whether it's after 2010 or not. Okay. So I'm just creating a variable for whether the person is 14 years of age or not, age 14, 0 if It's not a 1 if it is. Now, what is the equation for the difference in difference? The easiest way to explain this is you will have basically two lines, and and they will have a common trend. So one way of modeling this is the following. You model the outcome variable. In our case, that's the number of visits, right? And then you have a treatment dummy, and that's going to be 1 for those who are 14-year-olds, okay? It's going to be 0 for everyone else. And then you have a dummy for whether it is before or after the intervention. So in our case, it's a dummy that's after 2010. And you remember that was called copay in our article. We just created copay, and that's 1 after 2010. We also created this whether you're 14 or not. And then, and this is the key, we have an interaction term, which is what if the person is 14 and it's after 2010. And this is the key, because if this is significant, then the intervention had an effect, because being 14 and being after the intervention, if it goes up, for instance, number of visits, it means that they're distinct from the other group. There's a break in the trend there, basically, then. Okay, so in our terms, the model is, we're going to model the number of visits per capita. That's what it's called. Being 14 is a variable called H14. This dummy for whether you're before or after 2010 is just called copayment. And then we're going to model being 14 and interaction with after 2010. Actually, it's after 2009, or if you include, like 2010 was the first year when they did not have to pay. So it's an inclusive after. So let's do this. And we did something wrong. Oh, of course, this is just, this is not the code. This is just me trying to explain things. So there we go. We have the number of visits in the model, and we're going to use the OLS to estimate this model, and the data is in data frame number 2, and we're going to fit the model, and then we're going to present the summary. There we go. Notice how the summary becomes nicer if you use print in front of it. So print res, I call the res results res now, summary. So did the reform have an effect? Look at the intervention here. Yes. It seems to be the case that the number of visits went up by 0.15. Is that big or small? Then you have to compare it to the actual number of visits. And remember the 14-year-olds, they usually went to the doctor about once a year. So if it increased by 0.15, that's quite significant. It's like 15-16% increase in the number of visits. Is it statistically significant? Well, nah, not really, because I mean, you should also think about how many observations we have. It's not that many. We don't have a lot of years. We don't have a long time period before and after. Now, there's one thing you could do in addition to this, which would be the following. You could add year here. That's a common variable, right? Year. So let's see what happens if we add year. So all other variables that are supposed to affect the number of visits could be added here. Remember, we had an effect of 0.15 about, and now we'll have it's the same effect. Interesting. That's good, right? But now it's statistically significant here. So taking a year into account is now you're asking whether the line, there are two lines, and there's a jump in the line for this group around that copayment year. So that's basically how you do difference in difference analysis. You take the dummy for whether you're treated or not. In this case, those who are treated are basically those who are 14-year-olds, right? That's the treated group. And then you see, and this is always 1, even before the intervention. So this is just the number of visits for 14-year-olds basically have their own coefficient. And then you also see whether You have a dummy that says something about whether you're before or after the intervention, right? And then the interaction, and this was the key, because if you're both after the intervention and the group that's treated, and if you still find that this is significant, then that's the effect of the intervention. Thank you.